Hello, this is video 11 out of about 22 videos that we have for you, and it's on the topic of safety, which can be quite important. Now we're looking at safety both from a human standpoint and then also from an equipment standpoint. In other words, making sure your equipment stays functioning properly. As you know, we have two versions of our fertigation book, one in English and one in Spanish, and there's the web address that you can use to download them for free. Plus, this video and others on lab exercises and other lectures are available using this address here on the ITRC website. The general ITR website is www.itrc.org. The first topic on safety is one that regulatory agencies focus on, and it's safety regarding the water supply itself, and it's called backflow prevention. The idea of backflow prevention is you want to avoid having any chemicals go back to a water supply. And this, of course, is especially important in cities which have very strict requirements, but it's also required for well installations. The actual rules and regulations depend on the location. By the way, we have a whole chapter on this in the book. And some states, like Nebraska, for many years have had regulations that focus on nitrogen going back into groundwater wells. This, I think, is a little misguided because most of the nitrogen that goes into the groundwater comes from leaching, over irrigation, non-uniformity, that type of thing. Nevertheless, it's a good idea. But this backflow of nitrogen from chemical injection systems into wells is definitely not the major cause, or even, I think, a significant cause of contamination of the groundwater. Now, in California, the primary concern on backflow prevention has been in regard to pesticides. And that's what the EPA also focuses on, is prevention of pesticides from going back into the groundwater. Anyway, regardless of the reason and the little details, it makes sense to just not have backflow into your wells, and it's no big deal to prevent it. Just so you know, if you're pumping out of a regulating reservoir, even though you have a groundwater supply, ultimately, if there's an air gap between your well pumps and the reservoir, you don't have to worry about backflow prevention somehow getting back into the wells. So this is not for every installation. The most simple way, you might say, to avoid backflow water and chemicals into the supply, like into a well, is to have an air gap, and that's what you see here with these. And that's of course what we have on our household sinks. We have codes, construction codes, and if you go to your sink, your faucet should have its discharge above the top of the sink, and that way there's no water, no way that water will ever go backward into the faucet. Like if there's a power outage and you get a vacuum in your water supply line, would it suck water out of your sink? And the answer is no, and that's for a safety reason, for health. The problem is this picture doesn't quite match what you have when you have a well plumbed directly into a pump that goes to a drip system, something like that. This picture, in which the water goes into a concrete stand, is for surface irrigation, typically. The book describes in detail what you have with a what's called a backflow prevention valve. And there are different designs, but basically these are the ingredients. What you have is you have to have a spring-loaded check valve. And if you notice the arrow going to the right, the blue arrow going to the right, that's the direction of the flow. So that check valve opens up automatically. It's just spring-loaded. It's normally closed. It opens up when the irrigation water starts to flow through. If you notice all the other stuff, all the other apparatuses like the inspection and vacuum relief and low pressure drainer on the left side, or the upstream side and you inject chemicals on the downstream side. In other words, you don't want any chemicals to go backward through the check valve and so on. So you have the legislation and that the regulations for EPA for pesticides. For pesticides say that you have to have all these components. You have to have a spring-loaded check valve. You have to have a low-pressure drain. In other words, what happens is when the water shuts off, anything that is remaining in the pipe there, if it's not under pressure, it'll drain out. Those are always a hassle. They tend to leak and stuff, but that's the way it goes. There's an inspection port on the upstream side, and there's a vacuum relief. The vacuum relief is to prevent a suction on the well side. Now, just so you know, for potable water supplies in cities, the codes are much, much more stringent. Take a look at these diagrams. You don't have to deal with them all, but you know, there are a lot of springs and gizmos and you're talking a lot of money, a lot of pressure drop, and you actually have inspection programs where these guys come out and they're certified and they inspect these things periodically. But also take a look at the size of the pipe. It's really small, you know, and in ag we typically use a lot larger pipes, and these huge pressure losses that you have across these would cost a lot of money to overcome in terms of power bills. And so the ag industry has argued successfully that this type of more complex backflow prevention is not necessary in agricultural installations. So these are not typically what you find. You do find sometimes you'll find a local irrigation district that requires something like this, but not usually. So the book is on fertigation, but you can't get away from the fact that many pesticides are also injected with some crops. And it's fairly highly regulated. As you probably know, in order to inject pesticides in most states, you have to have the recommendation by a PCA or pest control advisor. And then on the label of the pesticide itself, usually there's a restriction that it can only be used if it's chemigated. That's a, you know, same idea as fertigation. It can only be applied to a specific crop, and often only using a specific irrigation method. And so it may be labeled specifically for drip irrigation, or maybe even for buried drip irrigation or subsurface drip irrigation, but not for furrow irrigation. For pesticides, the EPA it has quite an elaborate setup here that's required. It's on figure 2.7 in the book. Now this is quite a contrast to what you normally see in ag trade shows and so on, where people focus on the injector pump. If you notice here, there are a lot more pieces. You do see the injector pump kind of in the center bottom, but there are other little deals in there. There's a chemical flow meter, there's a hose, there's two check valves actually. One check valve for the chemical hose itself, and then there's another check valve for the backflow prevention, which I talked about earlier. There are two check valves that are required by EPA. And then there's also an automatic shutoff required on the electric pump that's tied in to the electric pump. In other words, if the pump shuts down, the injector pump is also supposed to shut down. So anyway, it's a fairly elaborate setup, and that is required by law for pesticides if you have a well supply. So again, to emphasize, the chemigation valve that was described earlier is just one of numerous requirements for EPA for a pesticide. So again, what we tend to focus on is the injector pump itself or injector device, and the chemigation or backflow prevention valve. But it's a little bit more of a systems approach that you often need. First of all, there's the check valve in the irrigation line itself. That's one of two check valves, and you know these just make sense in a well. I mean, why would you want your irrigation water flowing backward into the well? So that's a standard deal. And the fact that there's an air vent vacuum relief valve on the chemigation valve is no big deal either. We've been doing that for decades and decades. The automatic drain, that's something a little special. That's not been a standard thing. But a check valve and an air vent, that's, spring-loaded check valve and an air vent, that's pretty much standard stuff. Then the other check valve, though, as I mentioned earlier, is the one that prevents pressurized water from flowing back into the injector in the chemical tank. And it keeps things from blowing up and overflowing, that type of thing. In most books, including ours, you'll see a picture like this. You can buy commercial units that have a number of features in them that are really good. These little commercial units have a check valve that's built right into them. Usually there's a wand on it that actually makes it so that the chemical that's injected is injected midstream, and that helps mix the chemical with the water, and if you're putting acid in, that helps to minimize any corrosion that you might get on the edge of a steel pipe. And there's usually some type of on-off valve. So they're pretty good. Here's the thing though. They are for small chemical flow rates, like from electric chemical pumps. In some places, like in California, the Venturi injectors are very common. And what happens with Venturi injectors is they have both water and chemical going into the line. So you have about 20 times the flow rate going in, and these little devices here just aren't big enough to handle that. So basically you kind of have to make your own device, because you do want these functions. You would like to put the flow into the center of the pipe, and you want a check valve there for protection of both your equipment and for people. For large flow rate units where you mix the water and the chemical as part of the injection system, such as with Venturis, you need to make your own device, or there are some companies like Mazy who I believe sell some kind of injection port. But basically what you need there is you need a stainless steel check valve, and then you have to make some kind of a little gizmo that extends in the center of the irrigation pipeline. You can certainly do it yourself. I've certainly done it a number of times. This picture right here shows water. This is a demonstration, by the way, from Lodi pump, Lodi irrigation in the town of Lodi. It shows water coming in, goes into a booster pump, which you can barely see is something sort of blue on the left-hand side. The water is pressurized, and that's what's called the motive flow. It was already pressurized, but now it pressurizes it some more to overcome the friction loss through the Venturi, which is the black, sort of like a T-looking thing near the word chemical. That has a siphoning effect, a vacuum that pulls in the chemical. So what you see is water plus chemical going out and then eventually going into the irrigation pipe. Where it goes in, that's where you put your stainless steel check valve. And that's also where you fabricate something like a piece of PVC pipe that extends about halfway into the pipe. There are other details that are discussed in the book, but you want a high quality hose anytime something like chemicals are pressurized. It isn't very nice to have acid, for example, or pesticides get on you when something pops. And there should be a filter between the chemical tank and the injector. Chemical tanks tend to get residue in them for whatever reason. Doesn't make any difference what the reason is. And those can plug the injection device itself. And then the thing is, it's usually easy to filter chemicals or water. The problem is, how do you clean the filter? So there are things in the book that are discussed on how you can make connections, how you can develop connections, fabricate them so that you can flush out the filter, back flush it with clean water, and without having to take it all apart. This image shows such a connection where there's a filter. That's the uh, device on the right. You can see there's a chemical tank. That's the big thing. And let's see, there's a ball valve there, on off, so you can shut off the chemical if you want. And on the left hand side, you can sort of see it, left hand side of the T, that's an on off valve also, but that's to a water supply. That's the water supply. So what they can do here is they can shut off the chemical, they can turn on the water supply and run it through the filter. And if they want to, on the top of that filter, see there's another on-off valve. You can blow the water right through and clean it out that way, or you can yeah, basically you can do that, or you can flush it out anyway if you're going to inject another chemical for some reason. The black hose on the right then goes to the chemical injection pump, and so you can ideally you can purge this thing before you take it apart, and that's especially important with pesticides and acids. Remember the basic rules, because there are chemical incompatibility problems and they can't always be predicted. Don't mix chemicals together in tanks or hoses. And then try to space your injector ports apart a bit to minimize incompatibility problems. And use a different injector for each chemical. So just one injector is not very swift. If you notice on the bottom left, they have a pretty good deal here. The truck can pull up with the chemicals to the outside of the enclosure, the fence enclosure. There's a well-labeled valve, actually just a connection on a plywood backboard there. And you see the guys from the chemical company never have to get inside this enclosure and touch the chemical tanks themselves. There are pipes that go from these connections outside to the specific tank that's going to be filled up, and it's all well labeled. So that helps out. So do you inject upstream or downstream of the irrigation system filters? No doubt the safest procedure is to inject upstream of the filters, because if anything does get contaminated, if you have bad interactions, it'll get caught by the filters. But there are considerations. Acids may damage the filters themselves, depending on what they're made of. And then there's no doubt that the filter backflush water, if you just don't do anything special, is going to contain chemicals. Unless, of course, you have the injection intertied with the backflush controller with a lag time, and our video on purging chemicals from tanks discusses that. It's entirely possible to, but before you go into a backflush cycle, you stop your injection. You continue to have water going through your filters. And so what happens is any chemical that you have in the filters gets purged. And then, so after a certain wait time, then you begin your backflush cycle. So there are ways to get around it, and that's discussed both in that other video and in the book. There is another option, and that's shown here. If you notice on the far right, there's a special little overflow screen. It's actually, this one is sold by Fresno Valves and Castings, and they have a little booster pump on it. And all the backflush water in this case goes into this overflow screen, and it's recycled, and it's put back in the through the tanks. And then what happens is you clean off the residue that's on the overflow screen. And so what they're trying to do, it's people use these things for different purposes. Some people are very concerned about all that backflush water that's going somewhere, and they don't have much water to start with, and they're losing it. And so this way they recycle their water. This is one of the ways people do it. And anyway, what happens though is the backflush water can contain your fertilizer, no problem, and it just goes right back in because it's dissolved. And so this and other options are described in the book. You can see in the image behind me that there are tanks inside of tanks, and that's what this deals with here, containment structures for chemical tanks. They're sometimes required by local regulations, but other farmers just think it's a smart thing to do, you know. And usually they think it's a smart thing to do after they've already had some chemical spill. But there are two key items here. One is you want to make sure you use excellent bulkhead fittings. That's a term we use for the fittings that attach to the tank. You know, you don't want them to corrode, and that can either be the gasket or the metal itself. And so things like stainless steel and Viton gaskets are important. And you can check with gasket suppliers and find out what the various materials can withstand. And then the other is you know, you can, like in the picture behind me, you can put a tank inside of a tank, but everything is so tight that you can't really access the bulkhead fittings. If like, what do you do with if you have a filter down there? You can't even reach it. So the picture in this slide right here shows concrete bunkers, you might say, with more than adequate room to get in there and access the fittings and replace things. Chapter 2 of the book contains a pretty good section on sulfuric acid injection and safety. And we'd really like to thank Jim Gregory from Vertical Brothers in Hanford, California, for supplying a lot of the photos that we put in the book. And they try to really pay attention to safety. And you have to pay attention to safety with sulfuric acid. So there are a lot of rules, and really take a look at the pictures that we have there about how you should be very prudent and safe when you deal with strong acids. Things like add acid to the water, don't add water to the acid. If you put water on top of acid, it can get hot and boil and then shoot acid in your face. There's the, as this picture shows, there's PPE, you know, personal protective equipment. You should have face and eye wash equipment on site. You should ventilate your tanks. You should isolate the tanks, you know, don't have clutter. Basically, neatness is a big deal. You know, it's sort of like if you work with batteries, you know, at least I do. I have a little container of baking soda nearby, and I can sprinkle that on any acid that somehow gets around, or to clean off your battery terminals. And that's what this high carbonate materials deals with, so you can neutralize acid spills. You have to use special injector pumps. A lot of pumps, you know, you have to be careful of because they may claim to do well with acids, but they just don't cut it. The seals, the gaskets just deteriorate very quickly, but there are some excellent pumps available. And if you are uncomfortable with this, and really if you aren't comfortable with doing this personally, my feeling is you shouldn't have your workers do it either. You should contract it out. And that's done by many farmers, is they contract out the sulfuric acid injection and the equipment and the calibration and all that, and they don't worry about it. Now, lids are a big deal, and I'm talking here about lids and openings on filters primarily, but we do have a fair amount of lids and openings that just suddenly pop open, and they can kill you. I mean, these lids will just shoot out like a bullet, you know. I mean, they don't go that far, but they're definitely deadly. And you have to teach people to go beyond looking at a pressure gauge. You know, the old rule is you shouldn't open anything up unless it's not under pressure anymore. And you just cannot believe pressure gauges. They will read 20 psi when there's nothing, and they'll read 0 when there's something. And so you should find a way. What I try to tell people to do is find something that they can open up and that will shoot out water if it's under pressure, and you know that that's you know, it's still dangerous. Just find something. You may have to disconnect a hose or something on your backflush valves, something like that, to make sure that it's not really under pressure. So you kind of have to go a little slowly and teach everybody to be very meticulous about opening things up. There are special lids that are designed, special configurations where when you open them up, they leak and they shoot water out, but they don't explode. And those are really good to look for. These types of lids, in particular, these they're kind of like Victaulic, but they're not quite Victaulic connections. These are the ones that are, you can have that top just pop wide open when you loosen it up. So be careful with those. So this video has provided a snapshot of some of the important aspects of safety with fertigation and applying chemicals into especially pressurized systems. So be sure to look at the book, which has a whole chapter on it, has a lot more information, and we hope this helps you out. Goodbye.